So we're going to talk about, we're going to do more of this free body diagram stuff today. So the idea here, the scenario I'm asking us to look at is I've got two boxes and they are connected together by a string. And I think for the time being, let's assume that the string is attached to the ceiling. And then let's assume that the masses are, this is 2 kilograms, this is 4 kilograms. So one thing we want to know what the tension in the two ropes are. So the obvious first step is to draw a free body diagram. I have T1 up and I have T2 and M1G down. We'll call this guy M1. We'll call this guy M2. The free body diagram for this guy is going to be T2 up and then M2G down. And I'm being a little sloppy about my relative lengths. We know this thing is in equilibrium, so T1 should probably be roughly equal. The sum of these two, the sum of this one and this one, should be equal to that one. I can then write my free body, my Newton's second law equations. So I'm going to write M1, that is, right now we're talking about this device. So M1A is equal to T1 minus T2 minus M1G. And then I can do the same thing here. I'm going to write M2A is T2 minus M2G. And then what a technique I often like to use is to basically say, I'm going to add everything on the left together and everything on the right together to combine the equations. So that would look like M1A plus M2A is equal to T1 minus T2 minus M1G plus T2 minus M2G. T2 cancels out, and I'm left with M1, M2, A is equal to T1 minus M1G minus M2G. And then clearly if it's A is equal to 0, right, T1 gives us the result that is equal to M1, M2, all times G. So in this case, that would be 2 plus 4. So that would be 2 plus 4 times 10 would give us 60 newtons. Does that make sense? A way I like to think about this sometimes is to say, I'm going to imagine that I just have a box here, and I don't know what's inside of this box. Right? I do know what's inside the box, but I don't know the details. All I know is that this has my two masses in it. So what would be the net weight of this box? So a free body diagram would have T1 coming down, and what would be the weight coming out of this guy? So it's a 2 kilogram box and a 4 kilogram box.
It's 6 kilograms.
6 kilograms or 60 newtons. Okay, and I could write basically M1, M2, all times A is T1 minus 60 newtons. And again, if there's no acceleration, T1 is 60 newtons. So this idea of boxing my system and then just looking at the forces that leave can often be useful. You see in this case, I have a T2 and a T2 inside of there, but they were two forces in equal, sorry, they were two forces that had the same magnitude in different directions. So they actually ended up canceling each other out. You could argue that these are the action-reaction pairs, right? Block one, through tension, block one pulls up on block two, and through tension, block two pulls down on block one. So they're action-reaction pairs. They stay within the system, and they can be canceled out. Okay, so let's imagine now that I take this same system. Oops. Let's imagine now that I take this same system and I'm going to apply an upward directed tension of 80 newtons. How would I solve that problem? Right? How would I figure out what's going on? Right? What might I be interested in? I'm telling you that T1 is 80 newtons. So what might I be interested in? What could I think? Yeah. The acceleration. So question would be, what is the acceleration? What else might I want to find? The other tension, perfect. So I want to find T1 and I want to find T2. So one option is to use that approach that I just suggested. Okay? I'm going to draw a box around this system. And I'm going to say M1, M2 times A is T1 minus parentheses M1, M2 times G. So the acceleration is T1 minus M1, M2 G over M1, M2. And not to make a big deal about it, but I like this equation. This equation makes sense to me. Why does this equation make sense to me? What is it? In what form is it? It's all of the forces divided by all of the mass gives me acceleration. So if I don't end up with an equation that dimensionally makes sense, then chances are I made a mistake. So let's see, what do we get for an acceleration? Acceleration would equal 80 newtons minus 60 newtons divided by 6 kilograms is 20 over 6 meters per second squared, or 3 2/3, 3.67 meters per second squared. Did I do that right? 1/3, thank you. So what do I get for acceleration? It should be obvious that you get 3 1/3 meters per second squared. And I can use, so that makes the guy who said we wanted to get acceleration, but Ethan's not happy because I don't have tension. So how am I going to get tension? Right, so what I can do, or what I'm going to do, is do a new free body diagram for this guy. Well, the forces acting on that are T2 up, M2G down. So I'm going to write M2A is equal to T2 minus M2G. T2 is equal to M2A plus M2G, which is equal to 4 times, it's going to be the other way around, 3 1/3 plus 10. So that's 13. 13 times 3 is 52. 52 4/3, 53 1/3, right? 53 1/3 newtons. Very good with that idea, right? I could do it the way I did before, which is to say box 1, box 2, and say, you know, T1 minus M1G is M1A. I need one more. T1 minus M1G minus T2 is M1A, and T2 minus M2G is M2A. And then I could, you know, combine equations again and get the answer. Either way works. Suppose I told you that the tension was 40 newtons. The tension is 40 newtons. What's going to happen? Yep.
The entire thing will accelerate down, but not as fast.
So it'll accelerate down, and we project it a slightly less. So let's kind of do this methodically. Yes, sir. Yeah, that's T1. Great call. So T1. So let's imagine that we're given the fact that the tension is 40 newtons, and we want to just kind of do it in a step-by-step approach. So what's the first step to solving any problem like this, Martin? First step. We're going to draw a free body diagram. Okay, so again, with the same deal. We got T1 up, T2 down, M1G down, T2 up, M2G down. Masses are sort of same problem. So one thing that it's always good to do is to guess a direction for the acceleration. I'm going to guess that the acceleration is going to be in that direction. I'm going to be wrong, but I'm going to guess that direction anyway. And so I can come in here, I will apply all the formulas. I end up with M1 plus M2A is equal to T1 minus parentheses M1 M2 times G. Acceleration is T1 minus M1 M2 G over M1 M2. And if I do all this math out, I will end up with 20 newtons over 6 kilograms, which is going to give me 3 1/3 meter per second squared. But I have a minus sign here. 40 minus 60 minus 20 over 6 is minus 3 1/3 meter per second squared. And now I can go and say, well, if it has a negative acceleration, that means that if it was going up, it's slowing down. Or if it's going down, it's speeding up. And I don't know which it is, because I don't know what was happening before. Yep. Because so what the question was, why do we guess acceleration? And the reason for that is because I need to know what I'm going to call positive. So by saying that the acceleration was in this direction, I said everything going up is positive and everything going down is negative.